Hello everyone. So today let's solve the problem 494 target sum. Right. So let's see what the question states here. Just give me a second here. 1 second. One second. Yeah, just give me a second here. Yep. So the question, let's see what the question states here. We are given an integer array nums. Yeah, we are given an integer array nums. You can clearly see here, right, which consists of the integers. So and then integer target, right, the target that consists of the integer. So we can either place plus nothing but the addition operator or minus nothing but the multiplication operator here. We can either place addition or the multiplication, addition or the subtraction operator, sorry, before each number, and we can concatenate them to form an expression. Yeah, we can just place either plus or minus symbol before each number and concatenate to form an expression. We have to count how many expressions evaluate to the target. We have to count how many expressions evaluate to the target, right? So what we need to return basically the number of different symbol assignments that produce the target. Either we can just go with a plus or minus, only two operators allowed, right? Just keep this in mind. Yep. Yeah, so this is the question. See, let's come to the first, this one, what do we call? First example here. So we have nums, this one, this is fine. 5 times 1 target, we have 3, output we have 5 here. So there are 5 ways to assign symbols to make the sum of nums to the target 3. See here, this is one way. Yeah, we can just go with a 1 minus here. So first initially minus and then all the plus. See, minus 1 plus 1, so this gets cancelled, then 3. So this is also one thing. So this gets cancelled. This is 3, and this gets cancelled. This one, this 3, 1 plus 1. This one 3 actually. Right. So this is fine, and this one gets cancelled. Then 1 plus 1 plus 1. This one 3. Right. So this one finally, this one will lead to 3. Yeah, these are the 5 methods. There are 5 ways to assign symbols to make the sum of numbers to target 3. So we have to return 5 in that case. We have 1, target is 1. We have to assign this one. There is only one way, right? So we just have to output 1 here in this case. So they have given us wonderful examples just for the sake of understanding, man. Yep. Now, what shall we do? Let's discuss the approach followed by the this one complexities. Then let's write the code, right? So before hopping into the approach part, let me tell you one thing. So we will be going with a 2D DP to solve this particular problem. We'll be going with 2D dynamic programming or 2D DP to solve this particular problem. Let's move on with the this one approach part. So the first thing here would be we have to compute when sum equals 5, right? We have to compute when sum equals 5, right? If we let p uh, p be sum of numbers assigned plus if we let p be sum of numbers assigned plus and n the sum assigned negative, n the sum assigned negative here, or the this one subtraction operator, then p minus n will be equivalent to target, will be equivalent to target, right? So this is fine, I believe. P minus n will be equivalent to the target, and p plus 1 will be equivalent to the this one sum actually. P plus n will be equivalent to the sum. Yeah, this is fine, I believe. Next, we will solve those 2p equals target plus sum. That is equivalent to target plus sum by 2. See, when I say, I'll just write it here. 2p equals what I said, target plus sum. I'll just write target for T for the target and S for the sum. So this will be P equals, so I'll just take this one to this side, right? So this will be T plus S by 2 actually. Yeah. Now for the example, let's consider this example. We are considering the same example right here. So we will be going with P equals, what is the total actually? Total we have here is 1 plus 1 plus 1 plus 5, 5 times 1 we have. So we'll be going with, it will be 5 actually. 1 plus 1 plus 1 plus 1 plus 1, right? So this will be 5 basically. Mm, actually, this will be target plus sum, right? Target is nothing but 3 initially. This one, target is 3 and sum is 5 by 2. So it will be basically 8 by 2. It will be 8 by 2. Yeah, it will be 8 by 2. 8 by 2 will lead us to the 4 actually. 8 by 2 will lead us to the 4 actually. So this is the formula, target plus sum by 2. So this is fine. So we got 4. If target plus sum is odd, then or target is greater than sum, then answer is 0. If target plus sum, target plus sum, this one, this part, if target plus sum, if this becomes odd actually, or target is greater than sum, or target is greater than sum, then answer, we can just directly go with the answer 0, right? So just remember this. So here the problem reduces to counting the subsets of numbers whose sum equals p actually. Here subsets summing to 4. We have got the 4 right here. Subset summing to 4. So we will be making use of 2D DP here. We will be making use of the 2D DP, DP of ij, which is equivalent to the number of ways using the first I numbers to get the sum j, right? So first, the base case, we will be initializing DP of 0, 0 to 1, right? DP of 0, 0 to 1. For each number, either we can skip it or we can just take it, right? So for the example that we are considering here, this one, basically subsets of 5 ones that sum to 4, subset of 5 ones we have here, this one input we are considering, right? The subset of 5 ones uh, that sum to 4. So this one 4 we got here, total plus sum by 2. That sum to 4, right? 5 ones that sum to 4 are choosing any 4 of the 5, are choosing any 4 of the 5. So this one I can just write it like this, C of 5 comma 4 actually, C of 5 comma 4, choosing any 5 of the choosing any 4 of the 5. So it will be C of 5 comma 4 actually, this will be 5, this will be 5 actually. Yeah, so answer is 5 here in this case. So the output that we got here is 5, which is equivalent to the output that they have mentioned for the example 1 within the question. So our approach works absolutely correct here. So as we are completely familiar with the approach, let's do one thing. Let's quickly discuss the complexities part. So what will be the time complexity here? The time complexity would be big O of n into p. The time complexity would be big O of n into p, where p is nothing but sum plus target by 2. We have already discussed this one, where p is nothing but sum plus target by 2, right? So this is fine. And in the worst case, p, if uh, when p is less than or equal to sum, or in the worst case, p will be less than or equal to sum. Just remember this. So at most we can go with p of n into sum, right? So it's better to go with this, the time complexity, overall time complexity, because of n into p. Yeah. So the time complexity would be big of n into p. So what will be the space complexity here? The space complexity would lead to big of n into p as well, because we'll be making use of the 2D DP table. Yeah, we'll be making use of the 2D DP table here. So overall space complexity would lead to big of n into p. So the time complexity and the space complexity for the code that we'll be writing in the future would be big of n into p and big of n into p respectively. Now, as we are completely familiar with the approach and the complexities, we are good to write the code. Let's start writing the code, right? So let's try to implement or articulate the same thing that we had discussed in the approach, right? So first, let's go with the, we'll be making use of the length of the nums everywhere. So let me do one thing. Let me assign that one to some variable. Yeah. So we don't have to write that one every time. N equals, let me assign to the variable. This one, what do we call? Variable n. Next, let's compute or calculate the total sum of elements here. Let's initialize sum to 0. Then the next part is, let me go with the for loop here for int v of nums actually, sum equals sum plus v. So this is fine. Now, if absolute target is bigger than the sum, then it is impossible to reach, right? So let me go with here. If math dot absolute of this one target, so if it is greater than sum, if it is greater than sum, then let's return 0. Then let's return 0. Then sum plus target must be even to get the integer p, right? So how can I write that one? It has to be, sum plus target has to be even to get the integer p, right? So let's write the if condition, one more if condition. I hope this works. I can just write it in this way, right? Sum plus target, sum plus target. So this one, reminder module 2, not equal to 0. If it is not equal to 0, then we have to just return 0 in that case. Yeah, I hope this works. Let's see. Uh, P is the required subset sum that we need to count, right? So let me, we know this one. P equals nothing but sum plus target by 2. So this one, so here I'll just uh, go with sum plus target by 2. Sum plus target by 2. Next, let's create the 2D DPI, man. Yeah. So we'll be making use of the DPI set, right? Earlier itself. This is fine. DP equals. So this one will be new int of n plus 1 and p plus 1. So this is fine. The next step is let's go with the base case, nothing but 0 elements make sum 0 in exactly one way, right? So we don't have to choose anything, meaning choose nothing here, right? So this one will be dp of 0, 0. Let me assign this one to the 1. Next, let's iterate over each element, man. Let's go with the for loop. So this one will be int I equals 0, I less than n, I plus plus. So this is fine. For int j equals 0, j less than, and again j plus plus. So oh, this has to be j, this one has to be, we have to consider for p, right? Sorry, got confused here. J less than or equal to p, j plus plus. So this is fine. So within the for loop, if there are no ways to make the sum j with the first I elements, then we have to skip. So in simple terms, if dp of ij, the value if it is equivalent to the 0, then we have to skip. Skip means in the coding, we can just go with the continue keyword that the Java provides. So I'll just go with dp of I and j. If it is equivalent to 0, then let me give continue keyword here. This is fine. This is fine. Next, if we don't take the nums of I, then we have to add the existing ways to the dp of I plus 1 j, right? So this one will be dp of I plus 1 j equals dp of I plus 1 j plus this one dp of ij, dp of ij. Next, we have to take nums of I if it doesn't exceed p, meaning we have to add the ways to dp of I plus 1 and dp of I plus 1 into j plus nums of I. So let me write one more if condition here. J plus nums of I, if it is less than or equivalent to p, then I'll just go with dp of I plus 1 and j plus nums of I. Nums of I can write it in this way, nums of I plus, so this one will be dp of ij. Yeah, this is fine, man. I'll just come out of this one entirely. Now answer is nothing but the number of ways to get the sum p using all n elements. So this one will be dp of np in short, right? So we have to return dp of n and p, right? So we are done with the coding part, man. So let me format the code once and let me hit the run button. Yeah, the sample test cases are getting passed, right? So let me hit the submit button quickly. So you can clearly see here, all the test cases are getting passed. Means whatever the code that we have written works flawlessly for all the test cases, right? So I hope the solution part is completely clear along with the approach and the complexities. For now, this is it. Thanks for watching, guys.